Alright, now to address the whiffim. What's in it for me? Who here wants more money? Raise your hand. Yes, I see you raising your hand even though you're not. Okay, so let's say you want to double your money every year. If the value of a $100 investment doubles every year, its value after t years is given by the value with respect to t equals 100, the initial $100 investment, times 2 to the t years. Alright. Okay, this is a pretty straightforward formula. If t equals 1 year, then 2 to the 1 year is, so that's 2. 2 times 100 is 200. So you end up with $200 at 1 year, after 1 year. If it's 2 years, then 2 squared is 4. 4 times 100. So you have $400 at the end of 2 years. Very nice. The question is, what's the instantaneous rate of change and the instantaneous percentage rate of change of the worth? Well, what does that mean? Okay, well, let's take a look at that. We want to find out just how much is the account increasing in money at any given moment. Just like the milk, how much warmer is it getting at any given moment? Here we're saying how much more money is the account getting at any given moment. And we can do that by taking the derivative. So let's do that. The derivative with respect to time will be 100 times 2 to the t times the natural log of 2. Okay. So, let's take a look at that. When t equals 0.25 years, that's the first quarter, then v prime will be about $82 per year at that given moment. It'll have an $82 per year increase at that given moment. When it's been 0.75 years, the third quarter, then v prime becomes $117 per year. So at that given moment, there is a bigger amount of money going in per year, and that may seem pretty wild and strange, because you might say, well, why don't they just put regular amounts of money, the same fixed amount of money, all throughout the year until I get another $100? Here's what's happening with interest. In this money versus time graph, you've started with $100. So the amount of interest will be from this point, this amount. And they tuck that money into your account. So now you have more than $100 at the next point. And the amount of interest from this bigger amount of money will be more than the previous amount. So, well, it's so the amount going in will be more. And it keeps going in, getting bigger and bigger, so that if this is the amount of money in your account, then the amount of interest that will go in at the next point will be much bigger here than the amount of money that goes in due to the interest here. So that's why that is. Next, let's take a look at the percentage of change, instantaneous percentage rate of change of the worth. You can do that by taking a look at the derivative, the instantaneous rate of change over the overall function for the value in the account. And that will give us the percentage. I did that down here. So here's what the function is. Here's the original function. We can divide out these two things, leaving natural log of 2, which is about 0.693. That tells us that we have 69.3%. That is the APR we need. That is the interest we need if we want to double our money. Very surprising, yes? Maybe you thought, oh, I need 100% interest in order to increase my amount, my money, 100%. Well, no, turns out you don't, because the amount that's going into the account keeps growing and growing. So you only need 69.3%. Good news. Okay. So there's hope for us yet. And that's how the derivatives of exponential functions help us.